This is day 4 of Unit 7. We started today with this warm-up. So pause the video, take a moment, try the warm-up, and then check your answers. So number 1, I have x, and that stays where it is, but then everything else moves down to the denominator because of the negative exponent. So then I change that to the cubed root of 64x cubed, and that's to the 4th power. So I have x over the cubed root of 64 is 4, and the cubed root of x cubed is x, and that is to the 4th power. And 4 to the 4th is 256, and that's x to the 4th. And then x over x to the 4th is 1 over x cubed. So 1 over 256 x cubed. That's a 3 there on the bottom, is my final answer. Restrictions, x cannot equal 0. And that was a cube root, so no need for absolute value on that. Number 2, let's first, again, get the reciprocal. Whoops. Okay, that was weird. Sorry about that. All right, so we have the reciprocal of the whole entire base, and that's to the positive 3/2 now. So then 1 over, that's going to be a square root of 25x squared y to the 4th, and that's going to be cubed. So that's 1 over the square root of 25 is 5. Square root of x squared x, or you could write that as the absolute value x, or we can wait till the end to worry about the absolute value. Square root of y squared, y to the 4th is y squared, but that's going to be cubed. So I have 1 over 5 cubed is 125 x cubed. My pen decided to stop working. There we go, x cubed, and y to the 6th. Seriously? I don't know why it doesn't want to work. There we go. Okay. And restrictions, x and y both can't equal 0. And then absolute value I need to worry about here. So even root of something that comes out odd, that would be the x cubed. So we have 1 over 125 absolute value of x cubed, and then y to the 6th. X and y both cannot equal 0. That is my final answer. Okay, so today we looked at simplifying radicals, so continuing on from what we did yesterday. So we did do this earlier in the year, but if you recall earlier in the year when we simplified radicals, when we had fractional exponents, like in this case, x would be to the 7/2 because it's a rewriting from radical form to exponential form, x to the 7/2. We just left it that way. And at the time, remember I said that we would get back to that later in the year and we would no longer write it as a fractional exponent. Well, we're here. So from now on, we won't write x to the 7/2 anymore. 12 divides evenly, and that's not a problem. And we already know how to simplify the square root of 50. So we'll do that first. The square root of 50 we know is 5 root 2. So we have that. We know the square root of y to the 12th is y to the 6th. So we already have that. The piece that we need to simplify that we don't really know how to yet is the x to the 7th. So again, we have, if we divided 7 by 2, we'd have 3.5. We don't want a fractional or a decimal exponent. So what we want to do is we're going to rewrite that into something that I can divide evenly by 2. And I want it to be an exponent that's less than 7, can't be more than 7. So the closest to 7 that divides by 2 evenly would be 6. Well, I can't change the problem. It was x is 7, I change it to x is 6, so I have to have another x to make it okay that I just changed it, because x to the 6 times x is x to the 7th. So now it's okay. But the reason I did that is because 6 does divide by 2 evenly, and I get 3. So x cubed is what I get when I take the square root of x to the 6th. And then I'm left with just an x underneath the square root. So my answer, if I bring all this together, I have 5. I have x cubed y to the 6th, and then I have the square root of 2x. Now, this was an even root, so remember, that's when we have to check to see if we need an absolute value. The key thing is that the original problem had to divide evenly and get a whole number for the exponent, and that whole number has to be odd. So 12 divides evenly, but that gives me 6, and 6 is not odd. So I don't need absolute value around that. Now, while I'm looking here, x to the 3rd, you might initially think that, well, 3 is odd, so you might initially think you would need absolute value. You don't, though, because in the original problem, when we did the division, 7 divided by 2, that was not an odd whole number. Okay, I had to make it, I had to force it to be an x cubed, because I had to do that step there of breaking it down. When you break down and then rewrite it that way, it doesn't matter whether the exponent's odd or even, you'll never have absolute value around that. Because again, when I check the original 7 halves, that does not come out to an odd whole number. So I don't want to put absolute value around the x or the y, because that's not odd. So no absolute value in this one, just 5x cubed y to the 6 times the square root of 2x. So copy letter A, and let's give that one a shot. So we're going to do the pieces that we know how to do first. So square root of 18, that should be a piece of cake. We know that that's going to be 3 root 2. I'm just going to cross the pieces off once I deal with them. The x we're going to leave alone for a minute, because that's going to give us a fraction. The y is going to give us a fraction. The z, 4 divided by 2 gives me 2, so that's z squared. The a we'll deal with in a minute, and the b, 2 divided by 2 is 1. So that's b. I just took an even root of something that came out odd, and when I divided 2 by 2, I got that odd whole number immediately. I didn't have to do any rearranging of the b's. So that is when we need absolute value. Even root that comes out odd whole number. 1 is odd and a whole number. So need absolute value around that. So the b's are done. Now I'm going to go back here to the root. Well, the exponent here for the x is a 1, and the root is a 2. When the exponent's smaller than the root, you can't simplify it. So we're just going to leave that x underneath the root. So the x is done. Now, the y cubed. I need to take the square root of that, and I don't want to write it any longer like we used to. At the beginning of the year, I don't want to write it as 3 halves. So I need to rewrite it as y squared times y, so that I can take the square root of y squared. So I'm getting y times the square root of y when I do that. Now, because I had to do that, I would have had 3 halves, and because I had to do that where I had to break it down into parts, I don't ever put any absolute value around any of it. So no need, even though 1 is an odd exponent and it was an even root, I don't put absolute value because it was 3 halves power, which is a decimal. So I'm just going to bring that over here. So let's see, I have a 3 so far. I'm starting to run out of space. So I have a 3 so far. I'm just going to skip a little space here, and I have square root of 2x. I have a y, and I have a y underneath the square root, and I have a z squared, and I have an absolute value of b there. Okay, so I think I have everything so far. So I have 2x underneath the square root, I have a 3 outside, I have a z squared outside, absolute value of b outside, a y outside, and a y inside the square root. Okay, good. So we're done with the y's. Now, same thing with the a's. I want to break that down into something I can divide by 2 evenly. So that's going to be 4, and then I have 1 left. So that the square root of a to the fourth is a squared times the square root of a. So I'm going to extend my square root, put an a there, put an a squared in the front, and that is it. Now, the order that you write these in does not matter. Generally, you should have the number and the variables, and then the absolute value, and then the square root last. But the order that you write the variables in doesn't really matter. So that's my final answer. Next one. Give it a try. Copy it, give it a try. So I know the square root of 27, that's 3, root 3. M squared, the square root, that's going to give me m. 2 divided by 2 is 1. That's a whole number and it's odd. So that's in the absolute value. 10 divided by 2 is 5. And that is a whole number and odd. So that's going to go in the absolute value. Eventually, I'll put these all in one absolute value instead of separate ones. Z, 6 divided by 2 is 3. That is odd and a whole number. And lastly, 13 divided by 2, that's going to give me a decimal. So I won't have absolute value around it, even if it's, whether it's even or odd, it doesn't matter. But I am going to break down a to the 13 into a to the 12. And then a, so that I can divide 12 by 2 and get 6. And then I'm left with the square root of a. So let me bring that over here. So I have 3 a to the 6th. And I'm done with the a's now. 3 a to the 6th, and then I'm going to write my absolute value of m n to the 5th, z to the 3rd, n to the absolute value, and then I have the square root of 3a. Because the 3 was underneath, the a was underneath, the a to the 6th wasn't. The m n to the 5th, z to the 3rd was not underneath the root, but it does have absolute value around it. And I think I'm done. Next one. Okay, so we talked about square roots. Now this one's a cube root. So the nice thing about this is we don't have to worry about absolute value because it's an odd root, so no absolute value. But the more challenging part, I guess, about this one is that we're taking a cube root of 16. So we're really good with square roots because you've been doing that for years. You're not as experienced with cube roots. And so I want you to think for just a moment about what if we had the square root of 8? Well, we know what we would do there is think of the highest perfect square that goes into 8, and that's 4. And then whatever that's multiplied by, and that's 2. And then that's 2 root 2. We're going to do the same thing, except for we're not looking for the highest perfect square. We're looking for the highest perfect cube. So in order to do that, I guess I better figure out what the perfect cubes are. So let's run through our list. The perfect squares we kind of just have memorized there in our head. Perfect cubes, maybe not. So the first perfect cube is 1 cubed, which is 1. Then 2 cubed, well, we know that's 8. Then 3 cubed, and we know that's 27. Now, I'm already higher than the number that we're trying to take the cube root of, so I could probably stop for the purposes of this problem, but I'll keep going a little bit just so we can have our list down in our notes. So 4 cubed we know is 64, 5 cubed we know is 125, 6 cubed is 216. I think we're probably pretty good here. I don't know that we would ever need anything that big, but we could certainly continue if we needed to. So we just keep cubing numbers from there until we get to what we need. But we have a pretty good list. So looking at this list, I want to figure out what number, just like I did with the 8 and perfect squares, I want to figure out what perfect square goes into 16, and that's 8. So we have the cubed root of 8 times the cubed root of 2. And you just want to be careful to remember the cube roots because you don't normally have to write that 3. So the cubed root of 8 we know is 2, and then I'm left with the cubed root of 2. So the cubed root of 16 is equal to 2 cubed root 2. So 16 is done. Now we're ready to simplify the variables. So x cubed, the cubed root. Well, that's easy enough. 3 divided by 3 is 1. So we know we have x. Then we have I'm going to deal with the 4/3 and the 5/3 in a moment, but 6/3 is 2, so that's a squared. Okay, so now let's deal with those y to the 4th cube root. So just like we did with the square roots, we want to break that down into something that we can divide by. The only difference is now we're trying to divide by 3 rather than divide by 2. So I need to rewrite that as y cubed times y. The cubed root of y cubed is y, and then I'm left with the cubed root of y. So I'm going to bring my y here, and I'm going to add my y underneath the cubed root. Now last we have the z's. So I want the cubed root of z to the 5th. So I'm going to rewrite that as the cubed root of z cubed times z squared. Well, the cubed root of z cubed is z, and I'm left with the cubed root of z squared. So I have a z, and I have underneath the cubed root a z squared. So now I'm going to just bring all that together. Just try and organize this a little bit. So I'm going to bring all this here together to get my final answer. So I have a 2. I have an a squared, x, y, and z. A squared, x, y, and z. I already have the 2 there. I have a cube root, and then I have a 2y z squared underneath the root. Remember, this is an odd root, so no need to even think about absolute value. Okay, that's it. Next one. Okay, these you did in Algebra 1. Just a refresher, you can combine like terms. If you can combine terms if they're like terms. So when I see 3 root 24 and negative 1 root 24, well, I can combine those. That's just like 3x minus 1x. So that's going to give me 2 root 24. So then I have 2 root 20, and then I have negative root 12. I can simplify further because root 24 is 2 root 6. And then I have to simplify root 20, which is 2 root 5. And then I have to simplify root 12, which is 2 root 3. So now I'm going to simplify. 2 times 2 root 6 is 4 root 6. 2 times 2 root 5 is 4 root 5. And minus 2 root 3 on the end. Now checking, I don't have any like terms because root 6, root 5, and root 3 are all different. So that's as far as I can go. So copy B, give it a try. Pause the video if you need, and then you can check it. So 2 times square root of 9 is 3, that's 6, plus 3 times root 27 is 3 root 3. Then minus 2 times root 18 is 3 root 2, plus 2 times root 12 is 2 root 3. So I can simplify that a little bit. 6 plus 3 times 3 is 9 root 3, minus 6 root 2, plus 4 root 3. And I have a 9 root 3 and a 4 root 3, which can combine to 13 root 3. And now I have a root 2, a root 3, and a number without a root. They are not like terms, and therefore that's my final answer. Tonight for homework, you're going to complete pages 25 and 26 and just 21 to 29 odds on page 28 and 51 to 55 odds on page 29. Also remember you do have a timed exponents quiz tomorrow. 10 questions from that chart of exponents and 2 minutes to do that. So make sure you know your exponents for tomorrow.